Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Akgec Engineering College. So from today I am starting a lecture series on engineering mechanics, and today I am starting my discussion with the topic shear force and bending moment. So the first of all I want to clear why I have gone for this particular topic, shear force and bending moment, because as you can see on the slide, it covers two of my subjects, fundamentals of mechanical engineering and mechatronics, KME 201T, which is in first year, and in second year it is engineering mechanics, KME 402. So in both the subjects, shear force, bending moment is the content is there. So in shear force, bending moment, if I go with the question paper pattern, if I go with the exam pattern, then you can always find questions on shear force and bending moment either in first year or in second year. So that's why I have selected this particular topic, shear force and bending moment. So today what I will cover in this particular live session, I will be covering about the beams, statically determinate, statically indeterminate beams. I will be covering about the various types of loads. I will be taking various supports and support reactions, and definitely without problem solving it is not the class of engineering mechanics. So definitely some questions, some problems related to finding out the support reaction. This question may come in the mind of everyone, why the topic is shear force and bending moment and I am starting with beams. So the very first question is, what is basically the shear force and bending moment is? Shear force bending moment is the resistance offered by beam material against the shearing action and bending action. So it means the beam is offering certain resistance against the shearing. If I am saying shearing, then shearing means shearing, it is like this, and bending, if I am saying bending, then the bending of the beam. Okay, so like this we can see. So the beam offers certain resistance against what? Against the shearing action and bending action. Now the question comes, why the shearing action is there, why the bending action is there? Definitely there must be certain causes behind this. There are certain external causes behind this. These certain external causes are different type of loads and support reactions which are developed against the load. These are the two external causes which causes the shearing and bending action in the beam. So that's why first I am starting my discussion with the external causes for shearing and bending action. Then definitely in the next lecture I will be discussing about the shear force and bending moment analysis of the beams. So now let's start. Okay, first let me introduce the beam, what basically the beam is. Okay, so those who are present, please write good evening or Jai Hind, whatever, those who are available in the lecture. So please, okay, so that's why I am knowing how many of you are there, so according to that I will run my lecture. Okay, so the first is the beam. What is basically is beam? We all observe beams in different structures, yes or no? We observe beam in our home, we can find out beam. In many civil structures we can find out beams. So beam is basically what? Beam is nothing, it's a structural member which offers resistance to bending due to applied load. If I consider this as a beam, it can be a part of a structural member. Okay, structural member, what is the purpose of any structure? The purpose of any structure, is to support loads. And in particular, beam is that type of structural member, that element of that structure which offers resistance against the bending. Okay, so this, because of the load, this beam may get bent. So this is basically, so beam resists against bending. And specifically or particularly, if I am going with the specific definition of beam, so beam is a horizontal structural member. Here I was saying it is a structural member. Now I am coming to the some specific issue. It's a horizontal structural member used to support which type of load? Used to support transverse load. So in a structure we may find what? We can find many type of members which supports load. It can be a horizontal structural member, it can be a vertical structural member, it can be an inclined structural member, and these different structural members can be subjected to different loads. It can be subjected to axial load, it can be subjected to some torque, it can be subjected to some perpendicular load, which I am calling as a transverse load, which is perpendicular to its length. So beam is basically a horizontal structural member which supports transverse load applied at various point of its length. कहीं भी हो सकता है, anywhere it can be. So any kind of load it can be. So here I am talking about what? Here I am talking about the horizontal structural member for supporting transverse load. Transverse means, again I am clarifying this particular, transverse means perpendicular to length, perpendicular to length. Another thing which I can say about the beam is its length is quite large as compared to its cross section. Generally, if you are observing any girder, it can be used as a beam. We can find out the cement concrete RCC beams, in which what we are observing the length of that structural member is quite large as compared to its cross section, So clear? I hope now the topic is clear. What basically we are going to discuss here. Beam is what? Beam is, here it's a horizontal structural member to support transverse load. Now I am coming to the point, what are the different type of loading condition in beam? What are the different loads? Okay, it can be a concentrated or point load. It can be a, no issue in it, point load like this. I can write here F. This is the point load condition, concentrated or point load, no issue at all. It can be a uniformly distributed load. Uniformly distributed load means the load is distributed over the certain length uniformly. If I am considering this as a beam, then a layer of load is there, a layer of cement concrete is there, then the load is uniformly distributed here. If I am talking about a beam, then over that, if we are putting some cement concrete, then it is also the uniform distribution of load. If I am considering a tabletop and on which I am spreading books, then it is also the uniform distribution. So the load distribution, it means the load intensity is not changing. जितनी लेंथ की हम बात कर रहे हैं उस लेंथ के लिए. So it is the uniform distribution of load, UDL generally we call it. It can be a uniformly varying load also. It is not necessary that always it will be a uniform distribution. It can vary. It means if this is a beam, then load can vary. Here the intensity is lesser, then suddenly slowly gradually it is increasing. With the constant slope it is increasing. So it is the uniform variation of load. Just like a ramp, at ramp we can observe, so it is just like a ramp. So this is what the uniform variation. In my next slide I will be coming how we will be tackling with this uniformly distributed load and uniformly varying load. Okay, load, other than load, it can be a pure moment condition also. It can be a pure moment condition also. So this is what the different type of loadings which generally a beam suffers. Okay, I am not saying these are the only, but specifically these are the certain type of loading which we are dealing today. So in types of load, now you can see with the diagram. Okay, this is what the point load, this is what the point load. It can be a vertical load, it can be a inclined load. Here In beam, our concern is with the vertical loading, and it will be represented by arrow, downward arrow, definitely. This is what the UDL, this is what UDL, uniformly distributed load. Okay, the notations can be either like this, spiral type, or the standard one is this, a rectangular form. Uniformly distributed load, no variation over the length A, and the intensity of this load is W per unit run, matlab W per unit length. This is what the load. If I have to convert, if I have to deal with this load, then obviously for dealing with this, I have to convert it into a single point load. So what I will do, I will make this is the W per unit run, and the run is, the length is A over which it is spread it. So what I will write W into A, W into A. This will be the net effective load because of this UDL, and where it will be effective? It will be effective at the midpoint. So here you can find A by 2, A by 2. Okay. So UDL, again I am coming to that, uniformly distributed load. It will be represented in two manners. One, just like a spiral, the intensity of load is given W per unit run. W per unit run, here also it is given. Okay, W per unit run. A length over which it is spreaded. For analyzing purpose, for finding out or for tackling this particular uniformly distributed load, it has to be converted into a single point load. So if I am converting this into a single point load, then I will go with the W into A. W is the intensity, A is the length over which it is spreaded, so W into A. Now this single load will be effective where? It will be effective at the center of gravity of this, centroid of this, and centroid for this is center point. So A by 2, A by 2. So this is the UDL. Now I am coming to the UVL. UVL is nothing. UVL, the load is varying continuously with the constant slope. That's why I am saying it is uniform varying load, uniform variation of load. It is varying with the constant slope. Okay. And if I have to convert this into a single point load, then it will be the area of this triangle. And how much will be the area of this triangle? Here the intensity of the load is given W per unit run over the length A. It is changing from 0 to W. So the area of this triangle will be half into WO into A. Half into WO into A. So this is the area of this. So this is the net effective load. Net effective load of what? Net effective load of this UVL. From where it is coming? Just look at this. If I am converting it into a rectangle, then what it becomes? It is just like a UDL. If it is a UDL, then it will be W into A. I am removing the half of the portion, upper portion, then this will be WA by 2. So for keeping this in mind, it is the area of the triangle half into WO into A, and WO is what? It is the maximum intensity of the UVL from 0 to W naught in the length A. Now where it will be effective? This particular load will be effective just like the UDL is effective at the centroid of the rectangle. So I can say it will also be effective at the centroid of the triangle, and centroid of the triangle will be where? It will be 2A by 3. 2A by 3 from where? From the point A. It will be 2A by 3. So now I hope it is clear. So normally we are dealing with three types of loads: point load, uniformly distributed load, and uniformly varying load. UDL, point load, and UVL. Point load, no problem at all. UDL, W into A, effective at the center of the length over which it is spreaded. मतलब उतनी लेंथ जिस लेंथ पर वो स्प्रेडेड है उसके सेंटर पॉइंट पर. UVL, UBL. For finding out the single point load for UBL, it is half into W into A. How it is coming? I have shown this is the area of the triangle or rectangle में से आधा मैंने खत्म कर दिया. And it will be effective at which point? It will be effective at the centroid or center of gravity of this. So it will be at 2A by 3 distance from point A. So these are the different type of loads we will be dealing with. Now I am coming to the types of support, because I already told I am talking about what? The external causes which causes shearing and bending in beam. So the another thing is, that is the support reaction other than the load. So before moving to support reaction, now first let's know about the what are the different types of support. Simple support. Simple support. Suppose I am placing this on my palm, on my fingers. So this is the simple support. No, कोई अलग नहीं है. This is the only supporting, nothing else. So this is the simple support. Okay. So simple support. If one end of the beam rests on a fixed support, the support is known as simple support. This is fixed. ये मेरे palm fix हैं and it is supported. The beam is supported on this. So this is the simple support. It can be a roller support. It can be a roller support. Suppose this is a beam and on the one end of the beam I am putting some roller arrangement. I am putting some roller arrangement. So this is the roller support. Okay. So one end of the beam is supported by roller. It means the load will be taken by roller. So one end of the beam is supported on a roller. Another one is the hinged support. In the next slide I will be coming to how these all supports will be treated. So don't worry. Okay. If anything you are not getting or any doubt is coming, please write in chat box. I must know कि whatever I am saying, it is communicated or not. So okay. So it is the hinged support. Another one, hinged support. Okay. Hinged support. Suppose this beam is hinged here. If this beam is hinged here, what is happening here? What is happening here? So neither it can move in this direction nor in this direction. Only the possibility is the rotation. Only the possibility is rotation. Suppose, okay, so it is like this. If it is hinged, this is beam, this is the hinged one. So because of the hinge, neither it can move in this direction nor it can move in this direction because of the hinge. Whereas in roller, there is a possibility that the beam can move in this direction. But here, if it is hinged, so no possibility of translation in this direction, no possibility of translation in this direction. Only the possibility is the rotation. Only the. So this is what the hinged support. So the beam doesn't move either along or normal to the axis, but it can rotate. So this is what the hinged support. Another type of support can be a fixed support. Fixed support means I am holding this. Now I am restricting all the motions. Neither it can translate in this direction nor it can translate in this direction, or the rotation is also not possible if it is fixed. So these type of supports are known as fixed support. So this is particularly the different type of supports. Okay. So here it is written also, the beam is not free to rotate or slide along the length of the beam or in the direction normal to the beam. So therefore 3 reaction components can be observed, which is also known as built-in beam, which is also known as built-in support. Okay. Now I can see the different type of supports and support reaction. The first one is simple support. As I told, this is the simple support. I am putting this beam on my finger. So this is the simple support. Restriction. Now the question comes, reaction, what will be the direction of reaction and why the reaction is arising? The reason behind arise of reaction force is the restriction. Very simple. Wherever there will be restriction, there will be a reaction. यदि मैं आपको restrict कर दूं किसी particular काम को करने के लिए, obviously a reaction will be developed inside you. So the same thing is happening with the loads and beams and supports also. So in simple support, in which direction the restriction is? Beam can translate in this manner. Beam move कर सकती है इस direction में, but its motion is restricted in this direction, downward direction. So obviously against this particular action, a reaction will be developed which is upward, So you can see here reaction V, which is upward. So in simple support, reaction will be upward. Roller support, as I told, if I am putting the roller support here, roller support in the beam, if I am putting the roller support, the restriction is in which direction? The beam is free to move in this direction, but its motion is restricted in this particular direction. So the reaction will be vertically upward. It is not necessary to vertically upward. The plane on which the roller is lying, it will be perpendicular to that plane. So it will be normal, it will be perpendicular to that plane on which the roller is lying. Okay, clear. Now I am coming to the hinge. Okay, so hinge. If I am saying ki my this what it is hinged. ठीक है, this is hinged. If it is hinged here, जैसे हमारे डोर पर hinge होती है. So here what we are observing, is it possible to translate in this direction? No, restriction is there. Is it possible to translate in this direction? No, but the rotation is possible. So if the rotation is possible and restriction in translation, so the two reaction force will be developed. One against the horizontal translation, another one against the vertical translation. Okay, now I am coming to the fixed one. As I told, it is fixed one. So all the three motions, either the translation in mutually perpendicular directions, in these two directions, or the rotation. So all three motions are restricted. So if the motion is restricted, obviously there will be some reaction. So one horizontal reaction, another vertical reaction, and because of the load, the rotational tendency of beam will be like this. So against this, the reactive moment, the reaction will be there. So these are the different type of supports and support reactions. Now I am coming to different types of beams. As in beginning I told, two types of beam, statically determinate and statically indeterminate. So in general, these three beams, simply supported, overhanging, cantilever beam, these comes in the category of statically determinate beam, whereas in statically indeterminate beam, fixed beam, propped cantilever beam and continuous beam. Now I am coming to the point why it is statically determinate. Statically is coming from statics, static equilibrium. So for a two-dimensional force system, two-dimensional coplanar force system, how many conditions of equilibrium are there? There are three conditions of equilibrium: sigma fx equals to 0, sigma fy equal to 0 and sigma m equals to 0. So there are three conditions of equilibrium. Sigma fx, algebraic sum of all the forces in horizontal direction, in x direction, the sum of all these forces equals to 0. Sigma fy, algebraic sum of all the forces in y direction equals to 0. And sigma m equals to 0, algebraic sum of all the moments due to various loads equals to 0. So these are the different. So for finding out support reactions, what do we have? We have these three equations for finding out these support reactions. So if support reactions for any beam can be easily find out with the use of these three equations, sigma fx, sigma fy and sigma m equals to 0, then these comes under the category of statically determinate. So statically means static equilibrium, determinate means can be determined. So statically determinate beam. In next slide I will be coming why simply supported beam, overhanging and cantilever are as a statically determinate and why others are statically indeterminate. And statically indeterminate, obviously the opposite of this. If support reactions can't be find out with the use of these three equations only, then the beams will come under the category of statically indeterminate beam. So now I am coming to that, okay, why simply supported beam. Simply supported beam. So as I told, in simply supported beam, supports will be at the end, extreme end. Load can be of any kind. It can be a point load. It can be a uniformly distributed load. It can be a uniformly varying load. So this is the point A and this is point B. How many support reactions? How many reactions we are observing here? As two supports are there, so two support reactions will be there, RA and RB. Conditions of equilibrium हमारे पास कितनी है? We are having three conditions of equilibrium. So easily we can determine these two reactions. So it comes under the category of statically determinate beam. Overhanging beam. Overhanging beam. Okay. Now I am coming to overhanging beam. The meaning of overhanging, it means it is not supported at the end. Some part of the beam is hanging. It is free. Okay. So what does it mean? I am putting roller support here. I am putting roller support here, and at this point I am putting hinge support. Okay. These are the notations which we generally use. Okay. Loading. Here I am putting point load. Load can be of any type. Load can be of any type. So don't worry ki for this particular beam this type of load is there only. No. A, B. How many support reactions will be there? At A, there is roller support. So there is restriction only in one direction. So there will be one reaction force here, RA. Here it is a hinge. So at hinge there is a restriction in two directions. So there can be two reactions here, RBX and RBY. Why it is overhanging? Because this particular portion is not supported, it is in air, that's why it is overhanging beam. It is not necessary कि overhanging will be only on one side, it can be on both sides. This support can also be slightly inside, so that particular beam will be known as overhang from both sides. Okay, so this is the overhanging beam. How many support reactions we are observing here? 1, 2, 3. How many conditions of equilibrium we are having? 3 conditions of equilibrium we are having. So we can easily find out the support reactions. Okay, the third one is cantilever. Cantilever means one end of the beam is fixed. One end of the beam. So this end is fixed. This is what the A. This is what the free end B. Okay. Loads. Loads. These are the different loads. Okay. So because of these loads, what will happen with the beam? There is restriction at this particular support, as this is the fixed support. So there is a restriction. Can this beam move in this direction? No. So for this, there will be reaction RAX. Can this move in this direction? No. So there will be reaction here also RAY. Because of these loads, it is having a tendency of rotation in this direction. So against this, there will be reaction. There will be reactive moment. How many unknown reactions are there? 1, 2, 3. 1, 2 and 3. And how many conditions of equilibrium we are having for finding out unknown support reaction? We are having 3 equations, sigma fx, sigma fy and sigma m equal to 0. So this is cantilever beam. So all these 3 are statically determinate. Statically determinate. Now I am coming to the statically indeterminate beam. Fixed beam. Fixed beam. If the beam is fixed from both the sides. Okay. If the beam is fixed from both ends. If both ends are fixed, then load can be of any kind. I am putting only the point load. So don't worry. Don't bother कि it is only the point load will be there with this. No, it is not like this. Okay. So A and B, these are the loads. So how many support reactions, how many unknown reactions will be there? Restriction, restriction, restriction. So there are 3, RAX, AX or AY MA. Similarly, RBX, RBY, and rotational tendency in this direction. So MB. How many unknown reactions are there? 1, 2, 3, 4, 5, 6. Is it possible to find out with 3 equations? Mathematics doesn't allow this. Okay. So statically indeterminate. It doesn't mean these beams are not analyzed. These are analyzed, but not with the 3 equations of static equilibrium. Another one is propped cantilever. तो cantilever I know, cantilever तो मैं जानता हूं कि one end of beam is fixed, another end is free, another end is free. And what is the meaning of prop? Prop means supported by something else. So if I am putting one roller support here, in which condition I will be doing this? If the span of beam is very long, then there is a tendency of bending, there is a tendency of rotation. So in that particular condition, I have to put one support here, and by putting this particular support, now the unknown reaction forces are more than 3. Here vertical, horizontal, and rotational. Here at the roller support, there will be one more. There will be one more. So this is the 4 unknown reaction forces are there. Statically indeterminate. Statically indeterminate. Okay. Then it can be a continuous beam. Continuous beam means continuous beam. I am putting only the simple support. Continuous beam. Suppose if the span of beam is very long, then again it is not possible to support by only 2 supports. So number of equidistant supports are provided. Number of equidistant supports are provided. Okay. So as many as number of force supports are there, these will count in the, these will be counted in what? These will be counted in the support reactions. So if there are 1, 2, 3, 4, 5, 6, if the 6 supports are there, why we are putting the 6 supports? Because the span of beam, span means the length of the beam is very long. So for particular beam, we have to put the 6 supports for the equilibrium of this beam. So there will be 6 unknown reaction, unknown support reactions. So if there are 6 unknown support reactions, which are not possible to find out with the help of 3 conditions of static equilibrium. So if you are comfortable with all this, what we discussed up to now, we have discussed about beam, what basically the beam is. Okay, beam, अच्छा किसी बच्चे ने लिखा है कि सर प्लीज थोड़ा सा हिंदी में एक्सप्लेन करिए. तो बीम इज बेसिकली व्हाट? बीम एक हॉरिजॉन्टल स्ट्रक्चरल मेंबर है जो किसके अगेंस्ट? बेंडिंग के अगेंस्ट रजिस्ट करता है. ठीक है ना, बेंडिंग के अगेंस्ट रजिस्ट करता है. ओके, देन डिफरेंट टाइप ऑफ लोडिंग मैंने डिफाइन की. एक पॉइंट लोड हो सकता है, कॉन्सेंट्रेटेड लोड एट अ पर्टिकुलर पॉइंट. ओके, यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड हो सकता है, यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड, इसको भी मैंने अभी समझाया, अभी आपको बताया. ओके, अगेन व्हेन आई एम गोइंग टू द क्वेश्चन, देन थोड़ी सी हिंदी वहां पर यूज करूंगा, उस हिंदी से आपको क्वेश्चन करना कंफर्टेबल होगा. क्वेश्चन क्या आता है एग्जाम पॉइंट ऑफ व्यू से? एज आई टोल्ड कि एग्जाम में टॉपिक इंपॉर्टेंट है शेयर फोर्स बेंडिंग मोमेंट का. तो बीम से रिलेटेड व्हाट विल बी द क्वेश्चन? द क्वेश्चन विल बी फर्स्ट क्वेश्चन, द डिफरेंशिएट बिटवीन स्टैटिकली डिटर्मिनेट एंड स्टैटिकली इंडिटर्मिनेट बीम. So now we can differentiate between statically determinate and statically indeterminate beam. Yes, statically determinate and statically indeterminate. If I have to write statically determinate, हिंदी इंग्लिश दोनों में बता देता हूं. statically determinate, static equilibrium की we are having 3 equations of equilibrium. Determinate, it means I have to find out the support reactions, unknown support reactions. So if it is possible to find out unknown support reactions with the help of these 3 equations, then that will come under the category of statically determinate beam. Else it will be in the category of statically indeterminate. मतलब यदि मैं 3 इक्वेशन से अननोन सपोर्ट रिएक्शन नहीं निकाल पा रहा हूं, तो वो होगी हमारी स्टैटिकली इंडिटर्मिनेट। एंड स्टैटिकली डिटर्मिनेट में इट इज सिंपली सपोर्टेड, ओवरहैंगिंग एंड कैंटिलीवर। सो मैंने यहां डायग्राम्स के साथ आपको एक्सप्लेन किया है। ओके, simply supported beam, supported at ends, so there are only two unknown reaction in overhanging beam also. Certain part, कुछ part हवा में hang कर रहा है, it is not supported, supports are inside, it can be on the one side, it can be on the both side also. So this particular part is hanging. Unknown reactions कितने हैं? तो दूसरा क्वेश्चन जो बनता है स्टैटिकली डिटर्मिनेट इंडिटर्मिनेट के साथ एंड बीम के बारे में पूछने के साथ कि ड्रॉ दी free body diagrams for statically determinate and statically indeterminate beams. So in that way we can draw the free body diagram. Simply supported, supported at ends. Overhanging, दो सपोर्ट शो करिए, दो सपोर्ट शो करिए, कुछ पार्ट हवा में हैंग कराइए, देन उस पर फ्री बॉडी डायग्राम में सपोर्ट रिएक्शन शो करिए. इफ इट इज अ रोलर सपोर्ट देन देयर विल बी वन वर्टिकल अपवर्ड रिएक्शन फोर्स. If it is a hinge support, there will be two reactions. Two reactions क्यों होंगी? Because जब भी हम hinge की बात करेंगे तो दो डायरेक्शन में ट्रांसलेशन रिस्ट्रिक्ट होता है. So that's why it is RBX and RBY. So it is also statically determinate. In cantilever type of beam, there is restriction. Three restrictions are there. One, यहां से समझिए, if I am holding this particular beam, suppose this is the beam. So क्या ये मूव कर सकती है इस डायरेक्शन में? नो. क्या ये मूव कर सकती है इस डायरेक्शन में? क्या ये रोटेट कर सकती है? नो, नो पॉसिबिलिटी. सो अगेंस्ट हॉरिजॉन्टल ट्रांसलेशन RAX रिएक्शन, अगेंस्ट वर्टिकल ट्रांसलेशन RAY रिएक्शन, अगेंस्ट रोटेशन मोमेंट एट A which is opposite to the rotational tendency created by load. So three reactions. So that's why the cantilever beam, three reactions है unknown, तीन इक्वेशंस हैं. सो इट इज अंडर द कैटेगरी ऑफ स्टैटिकली डिटर्मिनेट. अब मैं आता हूं स्टैटिकली इंडिटर्मिनेट पर. ओके, स्टैटिकली इंडिटर्मिनेट फिक्स्ड. अभी कैंटिलीवर थी, एक एंड से फिक्स थी, मैंने कैंटिलीवर को दोनों तरफ से फिक्स कर दिया, तो तीन रिएक्शन इस तरफ डेवलप हो रही थी, दो रिएक्शन फोर्स, वन रिएक्टिव मोमेंट, तीन यहां पर होंगी. सो थ्री एट दिस साइड एंड थ्री ऑन द अदर साइड. So there will be 6 unknown reactions. So is it possible to find out? Mathematics allows us? No, it doesn't allow us. So that's why it is statically indeterminate. अब मैं गया किस पर? Propped cantilever पर. Okay, cantilever थी. So cantilever में how many reaction forces are there? 3. One horizontal reaction force, vertical reaction force, moment. Okay. But if the span of beam is very large, span of beam is lengthy, बहुत लंबी है बीम, तो वो क्या होगी? वो अपने ही आप बेंड कर जाएगी, अपने आप बेंड करेगी. उसको सपोर्ट किया, सपोर्ट करने के लिए एक प्रॉप दे दिया, दैट प्रॉप इज रोलर सपोर्ट. तो एक और रिएक्शन फोर्स बढ़ गई. सो वन मोर रिएक्शन फोर्स इज एडेड हियर. सो वन मोर रिएक्शन फोर्स, इट मीन देयर आर 4 अननोन. सो स्टैटिकली indeterminate. Then I am coming to the continuous beam. Continuous beam. If the span of beam is very long, very large, बहुत लंबी है beam, then number of equidistant support, same distance पर, equal distance पर number of supports are provided. Number of supports हमने same distance पर दे दिए, तो क्या हो गया? Number of unknown reaction forces increase हो गए. So this is also statically indeterminate beam. तो मेरी तरफ से जो क्वेश्चन फ्रेम होते हैं, फर्स्ट बीम क्या है, then differentiate between statically determinate and statically indeterminate beam, then draw the free body diagram for statically determinate and indeterminate beam. It depends on marks. If it is a 2-mark question, then 1 point definition is okay. If it is a 5-mark question, then we have to draw the free body diagrams and we have to justify with the number of unknown reaction force. So this is what so this particular question comes very often. You can go through the previous year question papers of engineering mechanics specifically, because KME 201T जो first year का है, it is the new subject, so only 2 or 3 papers are available, but engineering mechanics के लिए बहुत सारे papers available हैं where you can find small question related to beam and numerical which comes in exam. Now I am coming to the numerical part. Okay, क्या ऑब्जर्व कर रहे हैं भाई? सबसे पहले इट इज ए सिंपली सपोर्टेड बीम. इट्स अ सिंपली सपोर्टेड बीम बिकॉज सपोर्ट्स आर प्रोवाइडेड एट एंड, एट ए, एट बी. A to 4 मीटर लेंथ तक, क्या है ये? यूडीएल. दिस इज व्हाट द यूडीएल रेक्टेंगल से रिप्रेजेंट किया हुआ है. सो 200 न्यूटन पर मीटर, दैट इज द यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड which is spreaded over 4 meters. At the 4 meters of length, there is one more force which is 3000 of Newton. Okay, so this is the loading condition. Simply supported beam, supported at ends A and B. ध्यान से देखिएगा, बहुत सिंपल क्वेश्चन. देन लास्ट में एक क्वेश्चन करेंगे, वो थोड़ा सा अच्छा वाला करेंगे, पहले बिल्कुल आसान सा क्वेश्चन कर लें. ओके, क्या इक्वेशन है मेरे पास? आई एम हैविंग 3 इक्वेशंस. सिग्मा एफ एक्स इक्वल्स टू 0, यहां पर लिख दूं मैं, ठीक है. सिग्मा एफ एक्स इक्वल्स टू 0, सिग्मा एफ वाई इक्वल टू 0 एंड सिग्मा एम इक्वल्स टू 0. डू वी नो दीज इक्वेशंस? इनका मीनिंग मुझे मालूम है. सिग्मा एफ एक्स, डू वी फाइंड एनी हॉरिजॉन्टल फोर्स? इफ दिस इज अ वन सपोर्ट मस्ट बी ए रोलर वन, अनदर वन मस्ट बी ए हिंज वन. चलिए मैं इसको हिंज मान लेता हूं ए को. सो एट हिंज सपोर्ट देयर विल बी 2 रिएक्शन फोर्सेस. इट विल बी आर ए एक्स एंड it will be RAY. If I am considering it as a roller support, this must be roller support. So there will be one reaction force RB. So do be RAX, sorry, RAX. How many horizontal forces are there? I am finding only one horizontal force is there. क्या इस लोड का कोई हॉरिजॉन्टल कंपोनेंट होगा? इट इज वर्टिकली डाउनवर्ड. दिस इज आल्सो वर्टिकली डाउनवर्ड. सो आई एम नॉट गेटिंग एनी हॉरिजॉन्टल फोर्स. सो सिग्मा एफ एक्स इक्वल टू 0 जब मैं अप्लाई करता हूं, सो देन इट विल बी आर ए एक्स इक्वल्स टू 0. इन हॉरिजॉन्टल डायरेक्शन देयर इज ओनली वन फोर्स. नाउ आई एम कमिंग टू अनदर इक्वेशन, सिग्मा एफ वाई इक्वल टू 0. इसके सॉल्यूशन के साथ अभी हम चेक करेंगे, ठीक है ना. सिग्मा एफ वाई इक्वल टू 0. सिग्मा एफ वाई वर्टिकल फोर्सेस कितने हैं? आर ए वाई, आर ए वाई. दूसरा क्या है? आर बी. और क्या है? यूडीएल. यूडीएल को यदि मुझे एक लोड में कन्वर्ट करना होता है तो मैं क्या करता हूं? आई विल बी डूइंग द इंटेंसिटी ऑफ लोड मल्टीप्लाइड बाय द लेंथ ओवर विच इट इज स्प्रेडेड. सो 200 into 4. Another load is there, that is of 3000 इक्वल्स टू 0. आर ए वाई एंड आर बी अपवर्ड है, पॉजिटिव ले लिए. 200 into 4 यूडीएल है, डाउनवर्ड है, नेगेटिव ले लिया. 3000 इट इज ऑल्सो डाउनवर्ड, नेगेटिव. ओके, सो आर ए वाई प्लस आर बी माइनस 200 into 4 माइनस 3000 इक्वल्स टू 0. सो दिस इज द अनदर इक्वेशन. हाउ मेनी अननोन्स आर देयर? 2. So another equation is required. That another equation can be the moment equation, either about point A or about point B. So here I am choosing the point sigma m A equals to 0. My way of doing the question is very simple. जितने लोड हैं उतने मोमेंट के कंपोनेंट होंगे. Okay, so how many load components are there? There are, this is आर ए एक्स इक्वल टू 0. इससे तो कोई मोमेंट जनरेट होना नहीं है. नाउ आई एम कमिंग टू आर ए वाई. आर ए वाई, विल इट जनरेट एनी मोमेंट अबाउट पॉइंट ए? मोमेंट क्या होता है? मोमेंट इज मैथमेटिकली इट इज फोर्स इनटू परपेंडिकुलर डिस्टेंस, एंड दिस पर्टिकुलर फोर्स आर ए वाई इज पासिंग थ्रू पॉइंट ए. सो विल इट जनरेट एनी रोटेशन? नो, द डिस्टेंस इज 0. सो देयर विल बी नो मोमेंट बिकॉज ऑफ दिस आर ए वाई. नाउ आई एम कमिंग टू आर बी. आर बी, what will be the moment due to RB? The load is here, RB. What is the distance? 4 plus 4, 8. RB into 8. RB into 8. What will be the rotational tendency? Moment is what? It is the rotational tendency. तो ये A point के about, suppose ये A point है, यहां पर ये RB load है, ऊपर की तरफ लग रहा है, तो ये कैसा रोटेशन क्रिएट करेगा? Like this. क्लॉकवाइज और एंटी क्लॉकवाइज? इट इज एंटी क्लॉकवाइज. एंटी क्लॉकवाइज आप लोग जनरली नेगेटिव लेते हैं, मैंने नेगेटिव साइन लगा दिया, ठीक है ना. आर बी इंटू दिस. नाउ आई एम रीचिंग टू द अनदर वन. ये हो गया. नाउ आई एम कमिंग टू 200 into 4. दिस इज व्हाट? लोड. इट इज नॉट द मोमेंट, इट इज द लोड, यूडीएल. So I am writing 200 into 4. साइन इसका भी लिख देंगे थोड़ी देर बाद. 200 into 4. Where it will be effective? UDL कहां पर इफेक्टिव होता है? जितनी लेंथ पर स्प्रेडेड है उसके मिड पॉइंट पर, एट द मिड पॉइंट ऑफ द लेंथ ओवर विच दिस यूनिफॉर्म डिस्ट्रीब्यूशन इज देयर. सो अप टू विच लेंथ? इट इज अप टू 4 meters. इट इज स्प्रेडेड. सो ऑब्वियसली एट द मिड पॉइंट इट विल बी देयर. 200 into 4. And how much it will be? It will be 4/2. तो डिस्टेंस कितनी हो गई इसकी ए पॉइंट से? इट इज 4/2. टेंडेंसी ऑफ रोटेशन क्या होगी? टेंडेंसी ऑफ रोटेशन विल बी क्लॉकवाइज. फॉर दिस आई एम टेकिंग इट पॉजिटिव. ओके, नाउ आई एम कमिंग टू द अनदर वन. Another one. Which is the another one? That is the 3000. 3000. How much it is distant from A? It is 4 meters. So plus 3000 into 4 equals to 0. दो इक्वेशंस है, 1, 2. We can solve. सॉल्व करके जरा चेक करें आंसर यही आ रहे हैं या नहीं. प्लीज कंफर्म मी. Please confirm these answers are coming or not. चेक कर लें जरा एक बार, यही आंसर है या नहीं. 1700 और 2100. ओके, सो इफ द आंसर्स मैच कर रहे हैं, ये सबसे सिंपल क्वेश्चन था. अभी इसके आगे अभी और भी क्वेश्चंस हैं दैट वी विल बी डूइंग डेफिनेटली, बिकॉज विदाउट analyzing these, without solving these type of question, it is not possible to go directly for the shear force and bending moment. And ऐसा नहीं है कि ये question एग्जाम में इस टाइप के नहीं आते. Sometimes support reaction find out करने के लिए आता है. और shear force या bending moment के जो question है, या जब हम आगे trusses की बात we will be doing, then if you are finding the support reaction correctly, then also you are eligible for some marks. So support reaction means ऐसा नहीं है कि it is nothing. Okay, or once if your support reaction is wrong, the entire bending moment shear force diagram will be wrong, entire calculations will be wrong. If you are doing the truss, then the truss calculations will be wrong. So it is important part. Okay, क्या किसी ने आंसर निकाला? Has anyone? यदि किसी ने आंसर निकाला है तो प्लीज बताएं, कंफर्म करें. Okay, in my next class I will be talking about 2 or 3 more problems related to support reactions finding out, and then I will move towards the shear force and bending moment analysis. Okay, lecture को ज़्यादा lengthy नहीं करते. So in that way, so I hope if you are getting something from my lecture, from my live lecture, then thank you very much for watching this. Thank you very much.